Hello everyone. In this presentation I will solve this numerical example 2 regarding parallel circuit. In my last lecture I have discussed current division rule and numerical problem 1 regarding parallel circuit. Now if you see this circuit, here we have a potential source 64 volt, or the circuit current or total circuit current is 100 milliampere. So resistor R1, the value of this resistor is 1 kilo ohm. This is resistor R, the value is not given, but the current going through the resistor R is I2, and R3 resistor having value 4 kilo ohm, and the current passing through R3 resistor is I3. We have to calculate the value of R. Okay, we have to calculate the unknown resistance R from this circuit. Now let us solve this problem. Solution. We know that current through any resistor is equal to voltage across that resistor divided by value of that resistor. This is from Ohm's law, the very basic Ohm's law. The current is equal to voltage divided by resistance. So if we want to calculate the value of R, okay, the value of the resistor R, we need to identify current through that resistor, that means I2, and voltage across that resistor. Suppose the voltage across the resistor is V. Okay. Now, what is the voltage across resistor R? Since R 1 kilo ohm and 4 kilo ohm, these three resistors are parallel, and all these three resistors are parallel with our 64 volt source. Okay, so that means the potential drop across resistor R is none other than 64 volt. Okay, so the potential drop across resistor R1 is equal to, across resistor R is equal to 64 volt. So we have identified the voltage of the resistor. Now we need to calculate the current through this resistor R, which is I2. Now what is I1? At first let us calculate I1. We know that I1 is equal to V1 divided by R1. What is the voltage across 1 kilo ohm resistor? Since 1 kilo ohm resistor and 64 volt are parallel, so the voltage V1 is 64, and value of this resistor is 1 kilo ohm or 1k. That means this is 64 milliampere. Okay, 1 divided by k will give you milli. What is I2? What is I3? I3 is V3 divided by R3. What is the value of R3? The value of R3 is 4 kilo ohm. And what is the voltage drop across R3? R3 is also parallel with 64 volt. So the voltage drop is 64 volt. That means 64 divided by 4, which will give us 16 milliamps. Okay, I3 is 16 milliamps. Now we know that I total current is equal to I1 plus I2 plus I3 from Kirchhoff's current law. Okay, from Kirchhoff's current law we know the total current. Here I2 current is entering, I1 is leaving, I2 is leaving, I3 is leaving. So the summation of the algebraic sum of the living current is equal to the algebraic sum of current entering at this node, and IT is 100 milliamps, I1 is 64 milliamps, I2 is unknown, and I3 is 16 milliamps. So what is our I2? I2 will give us 100 sub 64 16. I2 is 20 milliampere. Okay, now I have calculated the current through resistor I2. We know the voltage across R, so we can calculate the value of R now. Okay, now what is I2? I2 is equal to V2 divided by R, or R is equal to V2 by I2. What is V2? V2 is 64, I2 is 20 milliamps. So 64 divided by 20 will give us 3.2 kilo ohm. So the value of this unknown resistor R is 3.2 kilo ohm. This is our answer. I hope you have understood this problem. Okay. In my next lecture, I will solve another conceptual problem. So that's for today. Thank you.